Hello, we are Team 2213-4, the Tech Sisters. My name is Jaya Chaudhary.
And my name is Pragya Chaudhary. With over 26 million cases of COVID-19 worldwide and schools and businesses reopening, it is important to innovate ways to remain safe while resuming normal life. Current methods such as fever scanning and facial protection do exist, but they can be ineffective and/or unavailable.
This is why we, the Tech Sisters, have developed 3 simple, smart, and affordable innovations to help restart normal life. The first is the body temperature screener, which measures people's body temperature before they enter public places to ensure that they don't have a fever.
The second is the protection helmet, which uses positive air pressure to provide better protection than a facial shield, while still allowing for identification. The protection helmet is also a social distancing monitor, using ultrasonic sensors to ensure that people remain 6 feet apart. The final is a simple, inexpensive, non-invasive ventilator to make ventilators more accessible. It is easy to manufacture and use to abate deficits in healthcare equipment.
One of the most common and definitive symptoms of COVID-19 is fever. Currently, essential workers have to stand outside buildings and manually take the temperature of people entering, which not only takes time, but also puts the essential workers at risk of infection.
To ensure people entering public spaces such as stores, airports, and schools are not infected while still protecting our essential workers, we have created the body temperature screener. The screener will be on the outside of buildings. It has a PIR sensor to detect human presence and a thermal imaging camera to record temperature. If it records a temperature that is at or higher than fever level, it will notify the person to go home and seek medical attention.
Let us show you a demo. This blue mug, filled with room temperature water, represents a person with a normal body temperature. When they approach the school building, their presence is detected by the PIR sensor, the thermal imaging camera performs a thermal scan.
Welcome. Please come inside.
And they are let into the building.
This black mug, filled with hot water, represents somebody with a fever. When this person comes before the building, their presence is detected, the thermal imaging camera performs a thermal scan.
You have a high body temperature. Please go home and consult a doctor.
And they are alerted to return home. As public spaces reopen, a new dilemma has been created. Face masks provide protection from infection, but obscure the face, a security risk, especially in schools. Facial shields provide identification, but do not provide the same protection as a face mask, leaving people to choose between identification and safety from infection.
This is why we have created the protection helmet. The protection helmet uses a fan to create positive pressure, which will only allow filtered air to come in through the top and will not allow any unfiltered air to come in from the bottom. It also functions as a social distancing monitor. It has 1 ultrasonic sensor in the front and 1 ultrasonic sensor in the back. If anyone comes within the 2 meter distance of the user, an LED will light up, alerting the user to move away. Let me show you a demo. Pragya is standing there reading the signboard. If I come within 2 meters of her,
the LED glows, alerting me to step away. The fan also starts, providing me with the protection of the filtered air. Let us show you the parts of the protection helmet in detail.
there are 2 ultrasonic sensors, one in the front and one in the back, to measure the distance between the user and any surrounding people. There's a fan covered by a filter to only allow filtered air to pass through. Inside, there's a particle photon to control the fan and the LEDs. There's a relay to control the fan power, and there are 2 LEDs to alert the person to move away. To separate your head from the electronics, there's a harness.
One of the key equipment needed in treating COVID-19 is a ventilator. However, ventilators are expensive and highly sought after. Therefore, we have created a simple, inexpensive, non-invasive ventilator.
The problem with current non-invasive ventilators is that they release the exhaled gas into the room, which carries the virus. This exposes the nearby people to the virus as well. Our design addresses this problem by running the exhaled gas through a hot water tank, disinfecting it before releasing it. Let us show you a demo. This ball represents a patient's lung. The inhalation cylinder first extracts air from the outside, and then it pushes the air back into the patient. Then
The exhaled air is extracted from the patient and pumped through this hot water to be disinfected.
We are monitoring the hot water's temperature using a temperature probe. The temperature is displayed on the monitor. If the temperature drops below certain
The
thresholds,
water temperature is too low. To ensure proper decontamination, please heat the water.
people will be notified to heat the water. Let us show you the parts of the ventilator in detail.
There is a Raspberry Pi with servo hat that controls this servo motor, which moves the pistons in the inhalation and the exhalation cylinders. These tubes supply fresh air to the lungs and extract the exhaled air to be run through the hot water, which is constantly being monitored by this temperature probe.